Good afternoon, guys. Can you please, anyone please confirm if I am audible? Is Pratyusha, can you please confirm?
Yes, sir.
Thank you. What about the rest? Everyone are able to listen to me? Are able to hear my voice? Yes. Okay. Cool. Hope everyone had the lunch, right? So there is not a single person who's going to sacrifice. Is not sacrificing a lunch, isn't it? Yes, I did upload the PPTs as well. If you had went to our Google Drive link, so I think Yesh had requested yesterday. So based on his request, I did consider and then uploaded the PPTs. Yes, guys, did you guys spend your 10 minutes of your time yesterday? Yes. Yesterday, I tried to complete the IBM. Okay. Yes, I do understand. Like sometimes there will be a technical issue from the IBM itself, from IBM skill build. So just wait for that and then you can say restart it or resume it later. Okay. Okay, cool, Shreya. Yes, guys, any questions from the previous class? So we started off with the difference between the machine learning and the deep learning, and then started off with the yes, yes, the layers, input layer, hidden layer, and then output layer. And finally, we ended with the activation functions, right? With mod function, ReLU, softmax, and then tanh. So what is the count? 327. Okay. So let me share my screen, guys. I hope my screen is visible, right? Yes, this is what we were done. Today we have to code with the feed forward networks. Yeah. So yes. Okay. So we started off with the difference between the machine learning and the deep learning. How machine learning needs some kind of human intervention to give what are the features that you want to consider. Okay, that the machine has to consider for be it the classification or regression. But coming to deep learning, you will not provide anything since everything will be learned from this neural networks itself. Okay, and it is similar to the neurons. Whatever we have this neuron in our brain, right? So it is the same way how these neural networks are also. So here we have input layer, a hidden layer, and then output layer. So input layer is where we are going to give the instructions, like the inputs. Okay, that information they get that they give to you in neurons. Okay, so these neuron will have some weightage or the strength. Okay, that will be given by the weights and then biases. Okay, then once you have this, to analyze what is the data that you have in one neuron to another neuron. Yes. Yes. Is there any doubt? Who raised a hand? Yes, Manisha. Yes, Manisha, you raised a hand a couple of minutes back. Okay. So, having said that, we went on with the key components. That is, what are the things that you will be considering in the neural network? That is neurons, connections, weights and biases, propagation functions, and then learning loop. So neurons are nothing but where we are going to give our information, right? Then once you have your information, you need to send this to different people, right? Like there are different neurons. So that sending, for you to send, you need to first create some way or links, isn't it? So that will be done by this connections. Then each neuron will have these weights and biases, right? That is to show the strength of each of your neurons or the input that you have. Now, once you have that, then you also have to get to see your data flow. How do you want your data flow to flow from one neuron to another neuron? That depends on the activation function, given the aggregated weight, aggregated what is that? Sum of both of your weights and inputs followed by the adding by the bias as well. Okay, and you're going to have this learning rule. So what is it going to do? So every time it is going to adjust, it is going to see what like how much is it learning. Okay, next we have this single perceptron and multi-layer perceptron. So it is like single perceptron meaning you're going to have a kind of only one hidden layer, and in case of multi-layer you'll have multiple hidden layers. So we got this deep learning name just because normal machine learning was not able to analyze or find the pattern. Okay, but with an advent of within inclusive of including our deep learning concept, that is hidden layers, you are able to get to know about all the intricate what is the patterns that are in your, be it any kind of data, be it any audio or image or video, anything. Okay, so these are all happening all because of this hidden layers. So hidden layers is where the complete magic happens. Okay, so we have this input layer. So everybody knows input layer is the way we're going to give our instructions, and this doesn't include any kind of processing. So this is similar to what do you say, the waiter in a restaurant, right? So he will not do anything. What he will do, he just get the order from you, and then he'll not get the order from the customer, and then he'll not go into the kitchen and then prepare it, right? He's just going to get the input and then give that instruction to that chef in that kitchen. So the kitchen is where the everything happens, right? The chef cooking and all, preparing and all. So that is where the hidden layers occurs. So what do you do in the hidden layers? You're going to analyze or you're going to find the patterns. Okay. Next, last is output layer. Output layer is where you're going to see the output. That is the what do you say? The results, whatever you have done, right? The training or whatever you analyze, you will get to see the result. So this is the activation function. Inputs, you will have inputs, and you're going to have the aggregated sums of your what do you say, weights multiplied by the dot product of weights and your inputs, that is x1, and you're going to add the bias as well. And once you have these, this activation function is to get you the strength. So if the what is that? If this average, if the z value is close to 1, okay, depending on the activation function, it chooses to give that neuron or give that neuron a particular value. Okay, next we have this activation functions. The main reason for using this activation functions are to get into this non-linearity. Okay, and yeah, if you see here, we are not having any one kind of straight line, right? The reason for having this activation function is to understand the patterns that are not in linear. Okay, meaning it is whichever the data, if it is in non-linear, you will be able to understand the pattern. Okay, and in case of sigmoid function, you will be having a S-shaped curve. Okay, here the range of value that you can consider is between 0 and 1, and these outputs are represented in terms of probabilities. So anything closer to a particular, if it is above a particular threshold and it is closer to 1, then it belongs to one class, and the other one, if it is closer to a 0 1, then it belongs to the remaining class. Okay, that is only for binary classifications. That is if you have only two outputs. Next we have tangent. So tangent is nothing but it is also an S-shaped curve, but if you see you're having this S, okay, that is centered. Okay, so it is to, if you can say, you can have come up with this if you want to balance between your data points. Okay, then you can consider this tangent. Okay, meaning what? If you're having any kind of values between not, you can consider in case of sigmoid you have 0 and 1, right? Okay, this is like not balanced. It's a kind of, you can consider what if you had any kind of unbalance. What if you want to analyze a balanced data? So in that case, what you can do is you can consider between the ranges -1 to +1. Okay. Next we have rectified. So rectified linear unit is very, very important, as it is going to, whatever the negative value that you're going to get from the each neuron, okay, that will be converted into 0. Okay, and moreover, so anything positive number, so that will be assigned to that particular neuron. Okay, so this is to tell you, depending on that value that you get, it directly pushes, or it is going to fire your neuron to the next neuron. Okay, and the software access, it is also used for, mainly it is used for like multi-classification. So we have sigmoid for binary classification, right? But in case of multi-class R classification, we're going to consider this softmax. Okay, and here if you see, it ranges between the classes from 0 to 1. And most importantly, even though we're saying this multi-class, right? And since it is going to provide you the output in terms of probabilities, if you're going to have 3 classes, okay, now we had this 3 classes, right? Like we had these things, it is definitely going to sum up to what is that, 100%. Is it clear? So this represents the distribution of the given input layer. Okay, whatever the output that you have come, you're able to get that 90% for this 5.2 output. So that really understand that that is going to get you to know that whatever the output that you're going to get at the last, it will be in terms of probabilities, and each probability will have its own contribution of that particular output. Okay, so next, heading on to this is a feed forward neural network. Okay, what is feed forward neural network? And the word itself, we're able to understand, right? So it is also a type of artificial neural network where you will have only one direction. Meaning what? You're going to only go in one way. You're not going to come back. Okay, meaning if you see, we have this x1, right? So how does this s1 is getting the data means? So here we have this x1. So x1, x2, x3 are the neuron, that the input that we have. Okay, then each of these neuron will have some weightage. Okay, so now what you're going to do, you're going to add these two. Okay, multiply, use the dot product between these two, and then add the bias as well. So whatever the output that you're going to get, that you will be going to send it to s1. Okay, similarly I want to do for this one as well. So this one will have a weight 3s weight s1. So this will have its separate weights. Okay, so if you see, you're going to go from, and with the help of this arrow marks, so what are you trying to see? You're trying to see that you're having in only one way: input layer, hidden layer, and then output layer. There is not any kind of coming back, right? Okay, so you want to have this feed forward, only you will be able to see your data being analyzed in only one way. Okay, starting from input layer, hidden layers, and then output layer. Why not what is it, we are going to we did consider about this back propagation, right? So back propagation comes only when you want to change your error, when you want to reduce the error. So what is error? Error is nothing but the difference between your actual value and the predicted value. Okay, if you want to see that, if you want to see a lot of error, you have to go and then reduce it, right? So for you to reduce that, you're going to consider this back propagation. So what will you do in back propagation? You're going to literally change all the weights from back. Okay, you will be getting some output. So you will going to go back to this layer and then change the weights. Similarly, you're going to go back to the previous layer and then change the weights. Similarly, you're going to go back to this layer and then change the weights. Now again, what you will do, you're going to start from here with a new weights. Okay, again you're going to do this feed forward neural network, then you're going to find the output. Okay, yeah, that's what I was talking about. Yeah, to explain this back propagation. So if you want to go from one way, that is from input to hidden layers and then output layer, that is what is feed forward neural networks. You're going to consider this backward propagation, that is you're going to have this feed forward. Next, based on the data that based on the result that you get, meaning the error, the main task or the main goal for you to have the in your mind is to reduce the error, right? So here as well, if you want to get more error, you have to go back and change these weights. Okay, so from not directly to this the first layer, but back. What is the last layer that you have? You have to update the weights. Similarly, you have to update the weights for this. Similarly, you have to update the weights for this. Then finally, what you're going to do? This one complete. Okay, this you're going to go for input this way, and then coming back. Okay, this is called as one epoch. Okay, with that one repetition. Okay, so epoch is very, very important. So epoch is nothing but the number of times you're going to meet, what is that, one full cycle, okay, of you analyzing your data, even your neurons. Okay, so in case of back, the reason for having this back propagation is to minimize your loss. Okay, so loss is nothing but what you can consider that is the error. Okay, so to do this, to reduce the error, you have this two optimization techniques. So optimization technique is voice is not getting clearly. Just a moment, let me check. Now is it audible? Okay, can you please explain the back propagation with an example? Okay, back propagation with an example. So let's consider you want to expect a particular task to be completed within 30 minutes. Okay, you have some work, you're predicting that you might complete that work by 30 minutes. But in reality, you will be able to complete that task in 25 minutes itself. Okay, so what is the difference here? Here we have 5 minutes of difference, right? Isn't it? Now you want to go back and then change it and then find what all has happened. Okay, or we can take an example of, did you understand this difference? Is nothing but the error. Now let's consider an example of you setting up your this one room temperature in your home. Okay, let's consider you want your room temperature to be around like 200 not 200, let's consider 22 centigrade. Okay, so now you would like you would set, okay, like what is that, you have this thermostat, everybody would have known this thermostat, right? So you're going to adjust this thermostat given. Now you will be able to predicting. Okay, so the desired the room temperature that you want is, okay, that is there, that is presently there is around 22 Celsius. Okay, now you want to go back and then see your what do you say, Mm, your room temperature by considering multiple factors. Okay, like using a particular model, you are able to find that they are getting around 25 degrees Celsius. Okay, now what is the difference between 22 and then 25? You are around +3, right? Like minus like 3 Celsius of this one error. So now we want to go back and then see the what is that what made this error. Okay, what made this 3 Celsius degree number. Okay, how did you get this difference of 3? So now we want to go back and then change. You will go back and then change the temperature, right? In the thermostat. So in the similar way, the changing the temperature parameters are nothing but changing the weights and the biases in a neural network. Okay, so the main reason is for you to change the weights and biases is to get to that particular level, that is 22 degrees Celsius. Okay, so in the similar way, what we're going to do is we'll be getting some value. Okay, that is you'll be finding the, so for finding the error, you will be using this mean squared error. In regression we used, right? So to know the difference between your actual value and then a predicted value, and if you want to square that, you're going to have a positive number, right? And given this, if you're having 10% of error. Okay, now what will you do? You will go back and then you try to reduce that to having closer to 1, having closer to, sorry, 0%, isn't it? So make sure if you're going to have an error, you have to make sure you're going to reduce it till, if it is, you have to make sure it will be closer to 0. Okay, meaning it is in terms of percentage itself. एरर ज्यादा आने से हम जाके पीछे जाके हमको changes करना है. Changes मतलब we have to change the weights and biases in each, or be it in a hidden layer or in ending with input layer as well. Okay, we have to do this keeping in our mind you're going to have a less error compared to the first one. Okay, you're going to do it every now and then. So if you're going to do it every now and then, one complete cycle of you going forward and then coming backward, while coming back you're going to update the or adjust the weight side. So this whole one cycle is called as one epoch. So similarly you're going to do it until when you're going to get less error. Okay, IBM certificate. Yes, it is about reducing the difference, yeah, between the output and the expected output. Correct. Yes, if you don't get any kind of error, that is what happens in terms of if you have like a simple data. Okay, you can consider this one feed forward neural network itself. Okay, that simple ANN would be fine. Next, the next slide. That's what I was talking about. So this one complete cycle is called as one epoch. So initially what you will have is you will have this inputs. So what are the inputs is nothing but you can consider in terms of image, you can consider the pixel size. Okay, each pixel you can have this as the input. So these inputs are nothing but called as the neurons. So these neuron will have its own weights. So by having this aggregation by the dot product of both of these x values and the weights, and by adding as well the bias, you will be getting some value, that is the z value. Now you will be using this z value into any kind of activation function. Okay, based on the result it will be able to check, it will be able to push. Okay, if it is value greater than 0, and if it is value greater than 0, if it has only positive values, you can consider that. You can consider, for you to consider this, you can consider a loop function, activation function. Okay, and based on the value that they get, it depends, it purely pushes the neuron to the next layer. Okay, so similarly it does it, and you're going to have this back propagation. The reason for having back propagation is mainly to minimize the error. Okay, how are you going to minimize the error? Initially you will have some value for weights like w1, w2, and everything, each one will have its own weight. Now we want to go back and then change each of those, not directly to the input layer, but output is there, right? Now you have to go to the and change here first thing. Now after you've done the changes, now we have to go here and make the changes. Similarly you have to do it until input layer, until the first weights. Then you have to come in the feed forward, like in the feed forward propagation with the updated weights. Okay, the similar way you're going to do until you're going to get less, until you get a value of error that is closer to 0. Okay, so the way of going back, okay, we're going to use, so these are nothing but what you're literally using some optimization technique, right? Optimization matlab kya hai? You're going to try to use some steps, okay, where you can improve your model, isn't it? So is taraf aapko optimize karna matlab there are like we have this gradient descent. So what is it, gradient descent? It is literally going to what is it going to do? It is going to reduce the loss. Okay, how does it go to reduce the loss? It is going to literally go and then repeatedly change the weights. Okay, and most importantly, gradient nothing but you can consider the partial differentiation. So everybody would have definitely had this what is it, calculus, right? Partial differentiation and all. So that is similar to this one as well. So we're going to go back and then change the weights of each of these in each of the neural network. Okay. Now in this also we have this 3 types. In the gradient descent itself, we have batch gradient descent, stochastic gradient descent, and then mini batch gradient descent. So batch gradient descent is, so we are going to use the gradient descent for what? To update the weights, right? Why do we have to update the weights? So that you want to optimize a model, meaning you're going to reduce the error. isn't it? So in this case, if you're going to update all the weights, okay, for your entire data set, for the entire data, then you can get this batch gradient descent. Now, if you want to use what is it, parts of them, okay, into mini small batches, then you can consider mini batch gradient descent. Next, if you want to individually, okay, go for each of your data sample that you have, and if you want to do it but personally, like for considering single data points, then you can consider this stochastic gradient descent. Okay, so depending on, you can use these and then see the results, and which one gives the less error, you can choose the respective one. It is not that you have to use this one itself, batch gradient or a mini batch stochastic gradient. So everything goes with trial and error method itself. Okay, hope it's clear, right? It doesn't change the previous one. It changes the previous one and then go back to the previous one until the input variable. That is what I was saying, right? So it is not only going to go for the last hidden layer. Okay, it is going to start from the last hidden layer and then reach till this input layer. Okay, so यहाँ से स्टार अपडेट करेगा, बाद में यहाँ आएगा, यहाँ भी वेट्स को अपडेट करेगा, बाद में यहाँ आके यहाँ भी वेट्स अपडेट करके फिर पहले से the new weights you will have, right? So this new weights will have this feed forward neural network. Again, it will come like you will have this weights followed by, you're going to have user activation function to push that neuron to the next new neuron, right? And similarly in the next hidden layer, similarly you're going to do it for the hidden layer, and finally you're going to get the output, right? Now you're going to check the difference, that is the error. Now it has to be less itself because you have updated, right? Then you're going to do it repeatedly until you get a error value that is very closer to zero. Okay, and most important is one complete cycle is called as a one epoch. Okay, now did anyone explore about what is a CNN? Now having we having learned about the deep learning, its layers, its activation functions, and its back propagation and all optimization techniques like gradient descent and all. Now we can directly get into convolutional neural network. So what do you understand by this term convolutional neural network? If you see a normal artificial neural network, it might not be able to find all the patterns in the image, like or find all the edges, all these things in a uh, image. Okay, so to get this problem solved, you want to come up with this neural network, that is deep neural network called as convolutional neural network. Okay, so any idea about what is this convolutional neural network, guys? Yes, first tell me what did you guys explain about what is the CNN, convolutional neural network? Yes, any idea? CNN is used to extract the features from grid-like structures such as images. Correct, absolutely, Sandhya. So let's consider you're going to have this. So initially, in terms of machine learning, we had this Excel sheet, right? Isn't it? And this Excel sheet had the textual format, textual data, right? And then textual data, number data, everything you had, and it was represented in a tabular form. Now it was very easy for the machine to code that particular column and make understand the feature, and then give a ask you to predict a particular value or take a decision on the different types of classes. isn't it? So what if you were to train uh, a machine regarding the images? So what are the examples that you can come up with the CNN? Any real life example that you can come? Because everybody are using this CNN technology itself. Yes, yes. So it has this ability to recognize the patterns or the edges or whatever the content that it is there in the image. It is all able to analyze it. Yes. Where in terms of image recognition, any examples? And where in terms of object detection? Everybody using mobile phone, right? Yes. So we have this face recognition, face unlock in our mobile phone, right? So what are we trying to do initially? So we are trying to train our mobile phone by giving our inputs, like our images. Now it is able to find some patterns. It is able to find some what is that edges, like the shape, everything, the eyes. So it is able to extract all these things, and based on this itself, it is able to unlock your mobile phone, isn't it? Object detection as well. So now you have crossed the traffic signal. Okay. Now even though there was no police in the near the signal, but you were able to get the bill, right? So how was it able to you are getting the bill is, so you have this camera enabled at the signal, right? So if you're going to pass, if you're going to, what are you saying, pass with the red signal, you will be marked with the fine. How does it happen? You need, if you want to, if you're getting billed, there has to be some person who will be taking the pictures, right? So that's taking the pictures and finding the object. You have so many steps in a vehicle, right? But why only a number plate? So if you want to focus on only one thing, that is your object is nothing but your number plate. So this is the where we're going to use the CNN concept. Okay. So anything related to grid-like structure, like image kind of things, we are going to use this convolutional neural network. Okay. So now let me share my screen. Sir, when we set the face lock, it takes only one image. Then how does the model learn? So you're going to set your face lock, right? And when doing so, are you going to have this just one angle? आप one angle देख के set करते हैं क्या? नहीं तो है ना? You'll be moving the left side, right side, up and down and all, isn't it? So why do you have to move that? You're literally making the your phone train that if you're finding any patterns to turning the left side or right side, it is able to extract आपका फोटो में रहे अन्य डेटा को एक्सट्रैक्ट करने के बाद then it is able to give you some output. Okay, that output is nothing but it is recognizing your face. Okay, so initially you want to train, right? So train करने के पहले ही you will be having your face in different angles. You're literally trying to make the what is that machine understand, okay, by giving different kinds of images, meaning different angles of your images. So whenever you're going to get that, after that, if you want to unlock it, you're able to do it only because of the CNN. Now by picture the number putting them on the source. Yes, that is what they do. Okay. So taking a picture of the number plate and putting this number on the source, the police they can get all the information to us. Yes, they can do. Okay. Now that's my screen. So let's get into CNN, that is convolutional neural network. So we're going to use this convolutional network. Why do you have to go for a convolutional network? Is so we had this ANN, right? That is artificial neural network. So why not only on an artificial neural network? Is because if you have too many data, okay, too many pixels are nothing but the image. If for each image you have these pixels, right? So this pixels are nothing but the colors that you have, and each of these will have its color. So and most importantly, the most important thing is whatever the color if you want to create, you can create by with the combination of RGB, that is red, green, and then blue. Okay, with these three in your hand, you can create any color you want. Okay, now what? Why do we don't use this ENNS? Reason for not using it is as there will be so many parameters. Parameters are nothing but the pixels. Okay, now this normal ENN is not able to analyze it. So to analyze all these things, so what are these pixels will have? Pixels will have its own shapes, right? Or edges. To find these kind of things, you need CNN. Why only CNN? Because it is only literally only made. It's like a special person where he's going to only look after analyzing the image kind of data. That too grid kind of data. Okay, is it clear? So I can just take a note. So it is also type of we have learned about the deep learning concept, the fundamentals. So inside these there are so many deep learning models, and one among them is convolutional neural network. Okay, and there also we have LSTM, another thing as well. But here we're going to only focus on convolutional neural network. So convolutional neural network are the type of deep learning neural networks where you're going to be focusing on the images. That is in terms of grid like your data. Okay. So this is how, yeah, this is what I was telling. So what you will be doing is, in the CNS will be doing is, it will try to get the shapes or the edges. That's it. At first time, it is going to consider your eyes. Second time, it will only consider your nose. Third time, it might only consider your lips. For fourth time, it's going to only consider your ears. So in this way, it will try to get all the information from your image itself. Okay, so how does it do? So it has a sequence of process, a sequence of steps to identify the output. So what does it do? It has, like, if you want to identify the edges, curves, and shapes in an image, so this will slide over a particular filter. Okay, so filters are nothing but the kernels that we can get, and these filters have its own value. Okay, pixel values. So what you're going to do is you're going to slide over to each image. Okay, first you're going to consider this whole small block, next this small block, and this next this small block. So in terms of this, in the same way, you're going to go to each image, small pixel, and then find the what is that, a value. Okay, you will have this weights and bases, right? So by given these, you'll be able to find the strength of that particular filter, okay, of that convolution. Next, whatever the output that you're going to get after you applying the uh, feature, what is that, your convolution layer and the filters, is nothing but the feature map that you can consider. Okay. And here as well, so the main thing is there are like 5 things that you can consider. First thing is you want to input an image. Now from that image, if you want to analyze, okay, if you want to understand, you're going to analyze from each pixel. What is that? From each boxes. So what are these boxes? Like these photos are like, and I think let's consider I have this image, right? Where is that? Yeah, you understand this. So initially you have this image, right? So these are all the neurons that you have, isn't it? So neurons you can consider, or pixel size you can consider, or the input variables, isn't it? So these you will be getting into here. Okay, understand this, what this whole, and these neurons will have the pixel values. Okay, each of these will have the pixel, right? These are nothing but pixels, isn't it? The images of pixel sizes of data. Now this will be converted into terms of values, and that will be fed into our hidden layers. So these hidden layers will be using a convolution layer, striding, pooling layers, padding, and then finally you're going to analyze all these things in the convolution layer. Then you're going to also the pooling layer as well. Then finally you will be able to find the output layer depending on the what is the classification model that you're going to consider. If it is a binary classification, you're going to consider sigmoid function. If it is a multi-classification, you're going to consider softmax activation function. Okay, so this is a clear understanding. So why do we have to use the convolution layers? It is to find these edges. Okay, find the edges or shapes in an object. Okay, now how does this work? This works. First thing is you input an image. Okay, what is an input image? You are going to give the input in terms of pixels. Okay, what are the pixels? Something but it can be 20 by 28 cross 28 or 32 cross 32, 64 cross 64. So these are all nothing but you have a data of like 10 in width and 10 in length or 10 in height, isn't it? So here what this will convolution layer will do is, so what are all the input image that you're going to have, this will slide. Okay, this input image will be what is that, multiplying with the filters that we have. Why do we have to filter? Why do we have to have filters? Filters are there to identify the edges, okay, or the shapes or the textures in our image. Okay, पहले तो हमको डेटा रहता है, वो डेटा रहता है ना, ये तो हमको पिक्सल फॉर्म में रहता है, ये पिक्सल फॉर्म में रहने थे, हम क्या करते हैं, we will be using this convolution layers. By doing this, just a moment. So this guys, sorry. Sir, your screen is visible or not? Yeah, I was not talking. So where was I? Yeah, we had this. The how does this CNN is going to work? Is let me. We have it. Yeah. So understand this. So how does the CNN work? Is first thing is what? This is the whole image, right? In this whole image, what you want to do is you're going to first consider this face. Okay, so this phase will also be you will be able to find the edges in this image itself, in the small image itself. How will you be able to find this? You will be applying these filters. Filters are nothing but the kernels. So this will do is this slide over to the starting from this box till the end box. These image will have this pixels, right? So these pixels will be converted in terms of numbers itself, isn't it? So these numbers will slide over to the next vectors that you can consider the filters. Okay, then you will have some what do you say, dot product. Okay, you'll be using the dot product to find the value. Okay, so in the similar way, what I'm going to do is you're going to get some small. So first you will have this big picture. Then then what you will do, you will find all the small edges, small edges or small pixels that you have in your image. That will be converted into then this in terms of feature maps. So what are these feature maps? Feature maps are nothing but the convolution of the layer that you have, that the image that you have. Okay, the image will be what is it, sliding over the filters. So why do we need to use the filters? Filters are used to get the extract the what is it, get to know about the information like the edges, textures, the shapes, everything. Okay, all these small changes or small result that will be shared. Okay, that will be got, and this thing will be shared to another layer as well. So again this will be going repeatedly until we get this fully connected layers. So you're going to have the final feature maps into this one fully connected layers, and then based on this you will be able to map that with the neuron that you have. Okay, the available. So each feature map will have its own neurons connected. Okay, from this you will be able to classify between the given the sigmoid function or the softmax function, you will be able to find the probabilities. Okay, and if you see literally have that image gone. Yeah, this you can see here. So in the output, like initially what you're going to have, you're going to give this as input. Okay, so you have this small edges in your hand, edges in your image, that is nothing but this pixels. So this pixel size is nothing but the input. So this input will be sliding over the feature map, the filters. So what are the output that you're going to get? That is called as feature map. So like this you will be having, then this will be sent into this fully connected layers, and here as well you will be connecting these feature maps, the outputs of these feature maps with the next layer, where you're going to have every connection with the from the previous one. And finally you're going to do some and again hidden layers, and then you're going to apply some activation function to find the different classes. So depending on that you will be getting this percentage, this probabilities. Okay, so let me confirm first. Yeah, how does it work? First you're going to give your input, then you're going to have this hidden layers. So hidden layers में हमको convolution layer रहता है. Okay, so first thing is you input an image, meaning you're going to give the input as in terms of your pixel size. Next, this pixel size of data whatever you have, this will slide over to the filters. So what are these filters? Filters will also have some kind of values. Okay, like pixel values itself, inclusive of both RGB. Okay, so this will slide over and then find its textures, find its image. Okay, and since you're going to have this, whatever the output that you're going to get when you're going to slide over your input image with the filters, that is called as feature map. Okay, so once you have this feature map, then what you will be doing is you'll be using this pooling layers. So why do we need pooling layers? Is it is to reduce the dimensionality. Okay, so we did come across this dimensional reduction in our unsupervised learning, right? So what does that? You literally going to reduce the number of features, keeping the important features in your hand, right? The similar way, what you're going to do here is you're going to, since you're going to have so many feature maps after applying the filters. So in that feature maps, what are the main features that you're going to consider? They are giving leaving out the other like inconsistent or not effective feature maps. So that for that you're going to use this pooling layers. So once you have this this you're going to have a combination of convolutional layers and followed by pooling layers. So you're going to do multiple times, then you're going to have the output in terms of feature maps, right? So these feature maps, after you applying these pooling layers and all, you will have some concise what is that the feature map that has the most strength. Okay, now once you have this you're going to connect to all your neurons. Okay, so that will be done into the fully connected layers. Fully connected matlab you will have all your feature maps connected to every neuron in the next layer. Okay, Why do we have to have that? It is to have to find the output. Okay, so in the output type, we're going to have to predict the between the multi-class or binary class, right? So that you to understand that, you're going to connect all your data into this fully connected layers. Okay. So first layer is what? You're going to have this input layer. So this is where our image gets, right? So if you see, this is our image, right? So what is it of? It is of 3D. Now this 3D stems of what? You're going to have height, weight, and then channels. So here, if you see, this image is of 32 pixel size. Okay. So here we have this 32 cross 32, right? So what does that represent? You have the pixel size of 32 cross 32 in width, 32 in length. And now you also have this cross 3. So what does this cross 3? Cross 3 is nothing but the channels. The channels are nothing but you have this RGB I've told you, right? Isn't it? So if you're going to consider one or like other thing, you can consider grayscale. Since you're going to consider only 3, it will be combination of red, blue, and then green. So red, green, and then blue. So with these in your hand, whenever you're going to have this 32 cross 3, whenever you're going to get this 3, it shows that it is a colorful image. Okay. So next, this is what I was talking about, the combination layer. First layer is input. So that is where you're going to get your data, and that is the pixels. Next, once you have this pixels, so this pixels will be sliding over the filters. So what are these filters? Filters are nothing but the kernels that we can consider. So we kernels में क्या करते हैं मतलब we will be able to find the edges. Okay. So what is this? Yeah. Let's consider. Okay. So you have this input shape. Okay. मतलब क्या है, आपका इनपुट वैल्यू है, ये है पिक्सल का साइज है, okay, इमेज का पिक्सल साइज. दिस इज योर x1, this is your x2, this is your x3, this is x4, and then this is your x5. And now for this image you are applying this filter, that is 3 cross 3. What is this 3 cross 3? Is nothing but the what is that kernel that you can consider, where this you will be doing sliding over, meaning you will be finding the dot product. What is the dot product? You'll be finding 9 into 0, 4 into 2, 1 into 1. This is the first, okay, value. Okay. Next, you're also going to use this one as well, 4 into 1. And similarly, you're going to do it for the whole convolutional. So similarly, what I'm going to do first thing is this box is this first 3 cross 3 matrix is done, right, with the filter. Next, you're going to go for the next one. So if you're going to move from, this is the first thing that you've considered, right? Next, what are you trying to do? You're leaving the first one and then going for the next one, isn't it? So in this case, you're not moving directly to the next thing, right? Now, if you see, slide is nothing but how much is your filter moving. Okay, is it moving from one data matrix to the other data? Just excuse me, guys. Hello, hello. Yeah. So what this will do? This will go to each of your input image. Okay, and this will be, you will be applying these filters. What are you going to do with this input image and their filters? You will be having this dot product and then finding a value. Okay, similarly you're going to go to the next filter, you're going to go to the next value. Okay, here if you see, you're not directly diving into the next values, right? You're literally going to the next one. So this you can consider it is moving with a one stride one, and it's directly diving into the next one. Okay, and rather than considering this one, so what you can consider is, you can consider that it is having a stride 2. How much is your filter jumping, or how much is your filter moving? Is it clear? So similarly, what you're going to do, you're going to apply these kernels to all your input image, that is in the pixel size. Okay, so finally you will be getting this value, right? So this is for your first row. Isn't clear? for the second row. This is the first feature map, that is 30, 16, 13, 34 are there, right? This is your first feature map. So similarly, you're going to do it for the next input values as well. Is it clear? So how does this CNN work? Is first is going to apply these filters. Okay. So what are these apply filters? Filters are nothing but these are the small matrices, the matrix like data values that you're going to have. So with these in your hand, you'll be using going to all the values. So this pixel size, the pixel data that you have, it will be converted into numbers itself. Okay. So pixels will be ranging from 0 to 256, right? So with this in your hand, you'll be sliding over to each of these filters when finding some feature maps. Okay. The reason for going over the images is to find the edges. Okay. And now you're going to see here, you're going to stride. Stride matlab kya matlab? How much is your uh, filter moving from one pixel to another pixel. Okay, that is called as stride. Next we have this padding. So padding matlab kya matlab? You're having your data now. Okay, now just like cricket players pad up. So by padding, what are they trying to do? They're trying to save their data, right? In the save their legs or some save their body, right? By getting it. The similarly, what you're going to do is just to save your just to have your data in the spatial dimension, you're going to consider this padding. Okay, it is like adding extra spaces for your images, extra pixels for your images. Okay, next I have this activation function. So once you have all these things, then you'll be having this activation function. So why do we need to have this activation function? To enable or to understand the small patterns or the intercept intercept or the small edges, features, everything that you get from your image. Okay, next we're going to use this one I was talking about. In case of activation function, we're going to use this ReLU function. So if you see here, we're going to use this ReLU function. So whenever the value, if you're getting a value for that after applying the filters and all, you will be getting the value in terms of numbers itself, right? That is the value for each feature map. And after applying these, if you're getting value anything lesser than 0, so what this ReLU function will do, it is going to give it as a 0 itself, meaning it will not consider any negative neurons or any negative values from your convolution layers or feature maps. Okay. Last thing, we have this pooling layers as well. So I forgot to mention this. So pooling layers are nothing but it is to, so you will have your feature map. Okay, this one whole thing is a feature map that you can consider. Okay, so here what am I doing is I am going to find the, so if you're going to consider this as whole first matrix, we have this 3, 2, 0 and 7, right? So if you're going to apply this max pooling, so what this will do is considering this feature map, it is so. So yes, guys, is it audible now?
Yes.
Okay. 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 Thank you, guys. Okay. I'm sorry. So I'm into this. So if I'm going to, yeah, polylase में क्या मतलब होता है? मतलब we will be having the value feature maps, right? So what are these feature maps? Feature maps are nothing but the input image that you're going to give, that will be sliding over to your filters, that is nothing but the kernels. So whatever the output that you get, that you will be getting in terms of numbers itself, right? So that is the size. So here, if you're going to consider this first matrix, okay. So what are this is the, you can consider the whole. This will be considered a different kinds of feature maps, right? So in this, if you're going to consider the first four matrix and then find the maximum one. Okay, so your pooling मतलब हम pooling में क्या करता है? It is like your dimensional reduction, right? So you're going to reduce the this is pooling layers. The reason why do we have to go to use these pooling layers? It is to reduce the spatial size in our feature maps. Meaning what? So whatever the data that you have in this space, okay? Meaning spatial dimension matlab kya hai? How much, how is your data being scattered over the space? Okay. Now, if you want to only focus on the respective effective data features that you have, meaning what you're in dimension reduction, what were we doing? You were having only extracting the we were extracting only the main or the effective features, right? Removing the inconsistent features. The similar way, what we're going to do is we're only going to consider the maximum feature values, feature maps value that you have from each of the from each of the feature maps. Okay, we will be having this values, right? So we're going to consider this. If you're going to consider this max pooling, what this will do is it is going to consider the only 7 value out of these matrix. Okay, and if you're going to consider this one from 1 0 and 1 3, you're going to consider 3, leaving the other 0 0 1. And in case of this matrix, that is 3 2 0 7, you're going to consider only 7, but not 3 2 0. So what are you doing? You're literally focusing on this only one feature map, isn't it? Leaving the other things. So you're literally reducing your dimensions, isn't it? So this is in case of max pooling. But what in case of average pooling? So average pooling is similar to just like you were finding the maximum value, you're going to find the average of all these three, of all these four, like 3 plus 2 plus 7 plus 0 divided by 4. So whatever the value that is going to get, that is the value that you're going to consider for the next feature map. Is it clear? So each of these feature map that you're going to have, you're going to consider these pooling layers. You're going to have these pooling layers only to reduce the dimensions or only to consider the best feature maps. Okay. Next, once you have your data, okay. So once you have your data, once you have also applied this pooling layers, the last thing is you have this flattening layer. So what is this flattening layer? So we did come across with this in our programming language, right? So program make karne ke time, like in terms of, I think when we're learning about NumPy. So given a matrix of 2 dimensions, like in terms of rows and columns, you were using this flatten, giving the array name, right? Where you were able to convert that given table into horizontal way or in a vertical way of allocating your data, right? So in the similar way, you will be whatever the data that you're having, it will be in terms of pixels itself, like the length and breadth. Okay, now you want to convert that into one-dimensional space. Okay, so for doing that, you're going to use this flattening layer. Is it clear? The reason for using this flattening layer is you're going to use this for your fully connected layers. Why for fully connected layers? Because in fully connected layers, what you're going to do is you're going to connect each of the neuron that you have. Okay, so this is what I was talking about. You're going to have input as your image, then you're going to have a layers of a combination of what is that? Different types of convolution layers followed by pooling layers, convolution layers followed by pooling layers. So here you will be trying to find all the small patterns, edges, features, everything in your data. So once you have that in terms of the image, then you're going to convert that into one-dimensional space using this flattening layer. Next, once you have this flattening layer, then you're going to convert that into, the reason for having this flattening layer is you're going to assign these one-dimensional values to the respective neurons. You're going to assign all those to the neurons. Okay, after applying this neurons, you're going to get the output. How will you get the output? After you applying the activation function. Okay, so either हम लास्ट में क्या मतलब फ्लैटन लेयर में वन डायमेंशनल में हो जाता है, बाद में we have to give all these one dimensional vectors, whatever the output that you're going to get, that will be assigned to each of the neurons. So this will have some patterns finding. Then after applying the activation function, since here we have 3 classes, hence we are going to apply the softmax. Okay, and if you have 2 classes, we are going to apply binary sigmoid function. Okay, so depending on the input value that you're going to have, and once you have that value, you're going to apply it into sigmoid function, the softmax function, right? So that output will be in terms of probabilities itself, and if you're going to add it up, it is going to sum up to 1 itself. Okay, so depending on that, you're able to predict that it is not a elephant or it is not a lion. It is exactly similar to zebra. Okay, so in this case, we are going to use this convolutional neural network. Okay, so to be tell you precise, so first thing is you're going to have this whole image. So this you're going to consider this small things to apply these kernels. So what are these kernels? Kernels are the filters where you want to use these kernels to identify the edges, pattern, shapes, everything in your data. So once you have identified that, after you have got this feature maps, you have to use this. Okay. So after you're going to apply this feature maps, then you're going to use this max pooling layers or pooling layers. So either you can consider max pooling or average pooling. So what are you going to do in max pooling layers? You're going to reduce the dimensions. Okay. So you're going to consider only your effective feature maps. Okay. Then you're going to do it again. Similarly, you're going to do it until you're going to analyze all your data. Then whatever the data that you're going to get the last, you're going to have that converted into one dimensional space. Okay. So one dimensional space आने के बाद you will be assigning these one dimensional vector values to each of the neuron that you have. Okay. इधर भी हम क्या कर सकते हैं? We will be finding to some patterns. So in this itself, we will be able to you find our using a particular activation function, be it softmax, or in case of sigmoid function, you will be able to find the probabilities of the classes. Okay. So you can see you're going to give an input image, then you're going to add these convolution layers followed by ReLU and then pooling layers. So this is what you're going to do for multiple times for all these hidden layers. And then finally you're going to have this flattening layer as well, where you're going to convert these image. Okay, whatever you're going to have in two-dimensional space, like pixels are you going to have, right? Height and width of the image, then that will be converted to one dimension. That is in terms of vectors in one form. Okay, for each of these new ones. This will be connected with the remaining layers in a hidden layer system. So here also we're going to analyze the pattern and analyze our feature maps, and based on applying the activation function, we will be able to find our classes. Okay. So what are the things? First thing is input. Next you have the convolution layer. Then you're going to apply pooling layers. Similarly, you're going to apply convolution layer, pooling layers. Okay, you're going to do it until the fully connected layers. Then in the fully connected layers, you will be applying the activation function to know your output. Okay. Yeah. This is what I was talking about. So initially, what am I doing? I'm considering this input of size what? Of size 28 cross 28 cross 1. Okay. Next, I'm going to consider this kernel size of 5 cross 5. 5 cross 5. Okay. Then what I'm going to do? I'm going to slide over each of the data that you have. Each of the data I have to find the nature maps. So here you have this N1 channels, right? So this represents our RGB value. Okay, channels. Okay, so in a similar way, you're going to consider analyzing all your convolution layers. Okay, and finally, you're going to between these, you're going to apply these map pooling layers, be it max pooling or average pooling. And if you also want to have this padding as well, you can consider this valid pooling. And we have this two types called as valid pooling, valid padding, and the other one is same padding, I guess. Okay, so valid padding में कुछ नहीं होता है. You want to consider the same pixel values, and if you want to add new values to your pixels, then you can have this same padding. Okay, of the same pixel size. So you're going to do it until you're going to have this fully connected layers. So fully connected layers में जाने का मतलब you have to, before that you have to convert that into use this flattening layer to convert whatever the image that you're having. Okay, the pixel size of channel that you have, that has to be converted into vectors. Okay, that is one dimensional space. This one dimensional space will be using some activation functions to get the output. Okay. And there are all the things that you're able to see the applications are. You're able to see in automotive, social media, healthcare, law enforcement, and optical character recognition as well. Okay, so coming to this applications. So what are the applications that you can consider? I've told you, right? Any real life example that you can consider? What is the first one? Now the first one is automotive, right? So what is the vehicle that first thing? It has a great is it? Everybody has heard of this car called as Tesla, right? Do you need a driver to drive that car? No, right? It's like autonomous, meaning it is a self-driving car. You don't need any kind of drivers, isn't it? So how does it happen? It happens by using this CNN concept, deep learning concept. Okay, so to describe that on this application, so what it will do is it will have some sensors. Okay, so what the sensors will do, it is going to detect the cars or the people or like any cyclist or any vehicle that is in front of it. Okay, next, what is going to, it is also going to recognize some, first it is going to use some sensors itself. Okay, so using these sensors it will be able to find the difference between a person and a tree, a vehicle, between a person, tree, vehicle, everything, and be it the traffic signs as well. Okay, so everything will be known to this. Okay, so coming to the social media as well. So social media as well, we have this platforms like Facebook or what is it, Instagram and all, right? Where you can quickly know your people who you can tag, or if you want to directly get into any kind of a recommended content or recommended friend for you. Okay, what kind of, depending on, meaning given any kind of visual data that I want to see, it is going to recommend you to suggest a particular product to be bought from you, right? Next, coming to the healthcare as well, you'll be finding multiple what do you say, uh, the images that which can't be analyzed from human eyes, it can be analyzed from machines, isn't it? It is happening all because of the CNN concept. Okay, be it from x-rays or MRI scans or CT scans. And if you want to have this law enforcement method, it is like if you're going to be a detective and all, and now you want to go back and then get into the forensic analysis and all. Now you want to find each of your individuals, persons, objects, like you can get the object of interest, isn't it? Or if you want to, what do you say, consider this facial recognition. So we're going to have this facial recognition for identifying a particular person, right? And if you have any kind of robbery in a particular place, you can get into the CCTV footage, and then you will get to know about who the person is, right? Right, sir. Yes, sir. Is it clear about the CNN? So if you understand this is more than enough. Yes, guys, you can take a break. Is it clear until now about the CNN? You're saying yes is because I need to give you a break, or did you guys understand? Really understand? Okay, guys, I'll take a break for 10 minutes, and then after you come, I'll conduct a quiz. So please attend that, and then we can wrap up the session. So more will try to have this transfer learning given at the first session, and then start out with the coding part. Guys, take a break for 10 minutes. So, yes, Pratik, we're going to use TensorFlow. Okay, the framework that we're going to use to get into this CNN architectures and all. Now, I'll be sharing the I'll be sharing the scanner for the quiz. So please scan that, and then you can attempt the quiz. Okay. So tomorrow I'm going to start off with give an introduction of the transfer learning as well. Then we can directly dive into CNN, followed by a couple of transfer learning models as well. Okay. Yes, guys, please scan this QR code and mention your name. I want everybody to join this quiz. This is to just to test your knowledge from just from this class about only CNN. Yes, guys, I'll give 2 more minutes. Please join. Move onwards. This mark will also be taken considered for your assessment marks. Okay. Okay, guys, let me start off with the quiz now. So, join my system and then type in this code. Okay, 6. Okay. This quizzes will be considered for an assessment. This may great impact. So to give you clarity, please yes, here, here, you confirm it. I'm audible. Yes. Okay. Yes, we do have. We consider the performance. These. This is these two are
Hello guys, am I audible? Hello. Okay, this quiz performance is also considered as an assessment. Guys, do you have any queries?
so I hope I'm audible now, right? So I have yes, I did ask and then I did also upload it to the Google Drive. Yes, able to yes. I have uploaded the PPT contents in the Google Drive, guys. Is to right, right. That you log in with the quizzes, was have this yes, we have got around 96%. Arpan, Rishi, and then Sneha Karkoli. Congratulations to three and the rest of them as well. Class IQ is around 87 percentage. Wow, cool. So this shows that out of 10 questions, everybody were able to correctly answer around 8.8 questions to 9 questions correctly. Okay, good guys. Okay. That 22,500 points are nothing but the number of the time that you have taken to complete the each question. Okay, if you're going to take one question like 10 seconds, you're going to have some points, or you're going to consider for the second question, you might consider 5 seconds or 3 seconds. So, as if you're going to take less time to complete to attempt a particular quiz question, you will be earning a lot of marks. Okay, the credit points. Yes, great guys. Can you assign any practice questions? सर लॉग इन करना पड़ेगा. लॉग इन कर लिया तो आपको अच्छा रहता है, because if you want to go back and then have a what is that recap, or want to go and then check your knowledge, you can do that as well. You can refer that quiz. Guys, if you have any other queries, you can do let me know. I'll try to upload the PPT content and followed by the readout as well, student readout. Please refer that for your reference to revise, and please do come tomorrow and then clarify your doubts. Get your problems, we'll give you the solutions. Okay. Yes. Thank you, guys. Guys, धन्यवाद सबको. कल तक. Okay. Bye. और कोई को भी कुछ क्वेश्चन है तो हमको पूछ सकते हैं. Or else you can leave the session. But you will get college credits after completing this course. I'm not sure with that, Aisha, because you'll be getting a certificate. But having shown the certificate into your college, you can ask for this some other credits. Okay, guys, thank you so much. Yes, I've been sharing the drive link every day, right? The same drive link, I'm going to upload the content. So please refer this. Okay, guys, thank you. Bye bye. You're going to receive your certificate based on three factors. One is you have to complete the self-paced courses, and you have to have at least 80 percentage of attendance in each of the class that we are conducting now. And lastly is you have to do a project, and the project has to be uploaded into our platform, your recorded video followed by documentation as well. So only considering these three things, your project, your self-based courses, and your attendance in the instructor-led training, all these three things will be considered, and then only you will be given the certificate. And I forgot about the assessment as well. So you will also be given quizzes in between the training. So we're going to consider that as well. So assessment meaning a quiz from our team and quiz from my end as well. You will get to see about the project details soon in like coming in the coming week, like the next week. Once the training is done, you'll have to do the projects, right? So for you to do the project, our team will be sending you the skill wallet credentials. So in skill wallet you will be finding the respective project. Okay, so you have to enroll and then start doing your projects. Yes, Mohit, you are absolutely eligible. But given that, you have to have some marks in the assessment as well. Okay, you regularly attending the class, you also have done the project. You also need to have uh, good amount of marks in the assessment as well. You will get to know the self-based courses, how many you have to do it. Once you get the skill wallet credentials, okay, don't worry about that. That yes, Mohan. Quiz results in terms of I will be sending the form as well, right? The Google form. Likewise, you had I think you had attempted it last week, right? So in the similar way, you will be having multiple couple of more quizzes. So please do attempt that and then secure the maximum marks. Followed by you also have to have good marks. Hope it's clear, right? So please confirm that so then we can wrap up the session. Thank you so much, guys.